Hello. Hello everyone. Today we would like to present our mini project about the IoT. We apply to create a smart refrigerator. Uh, the table of the content consists of six topics. The first is introduction, why we create this project and the objective. The second one is how that is work. We will show our system that we developed. And third is the node device that we show about the device deep down about the physical layer and the software layer. And the fourth is the workstation on the Docker. We will show through that we implement to define the protocol, database, and dashboard. The next one is the data pipeline on Node.js. We will show the function that we use to calculate data before set in the database and write application. The finally is the dashboard. Okay, let's start in our introduction. We use the board Lyrico T-SIM that use the ESP32 processing, including the sensor, camera, and microphone built into that can integrate the AI work. Therefore, we use this board to make our project. The objective, we assume requirement for refrigerator service and the user depend on the user story. The first one is the term refrigerator service. They can check the stock device already registered. They can set a new device. They can see the status update. When device registered, they can monitor all of device. By the way, in terms of the user, they can register their refrigeration by application, and another one they can monitor data and status on dashboard. Okay, how does it work? Before we will demonstration, we will show our system architect that we developed. We divide on three key parts. The first is a node device counting the product in our cabinet. The second is the live application that reply message on the live or chat. The finally is the workstation management that show the install tool application for protocol activity for database and dashboard. Okay, in this slide, we will show the demonstration about the smart refrigerator. By the way, normally the device will transmit data to parts. The first is the sending the working status. Another one is the setting the status update. The quantity in our cabinet depend on someone open and close the cabinet after every 5 seconds. The system will detect the number of product. In this case, we use the can brand the Nescafe. And send this information for record in the database for period 10 seconds. After that, return to the heartbeat status. Okay, we will show our demonstration. I don't know, could you see? Could you hear our sound? Okay. This is the overview of cabinet. It consists of the the button input that detect the door trigger. Okay. And the normal state, it will send the heartbeat. The heartbeat. If a device is online or offline, right now it's online. Okay. After that, when I hello. In this case, I assume we have two cans in the cabinet, and the button stage without work right now. Then I close the door. After 5 seconds, the LED will light it, and in this period, in 10 seconds, it will send the data. You can see in this case, they count 2. It's correct in the topic data. In this function for the counting, we use model to calculate before set in the database. And when after 10 seconds, it's back to normal state, then the heartbeat status. After 10 seconds, we don't have to go. And another demo, if I bring one can out of the cabinet, the data should be sent one. You can follow up this YouTube channel. Okay, this is for example about the guideline, how that is work in this cabinet.
แล้วก็เอากดหยุดไปก่อนก็ได้กดหยุดไปก่อนสต็อปแล้วก็ลาก
ไอ้เมาส์หายไปไหนแล้ววะ
เอามันอยู่นู่นนี้แล้วก็ลากPowerPointใช่ไหม
มันเป็น2 จอเลย
นี่เมาส์อยู่นี่ละ
Okay, in the next section, we will deep down on the node device by Kun Kanapi.
ไปมันดับไป
Okay, so first let's talk about the hardware. It's just for demonstration of our system. So we need total 5 components. The first one is 2 LED for provide a light source when we close the refrigerator, and then we need 1 button to indicate whether the refrigerator closed or open, and 3 100 resistor ohm for button and LED, and then simulated refrigerator cabinet, and then we need to have ESP2 port. So about the software, we have 3 simple steps. First is create the model, and then training the model, and then final deployment. So first, it train model with we need to collect image and level, and we modify the software that Professor provide a little, so it can level and collect up to 3 levels at the same time. So we have total 3 classes. We did M150 is energy link, and Nescafe is instant coffee, and flat is orange juice. The features show that it's quite put together. It's actually it's not good for the machine, good for the model. But anyway, we got 91%, and we have 270 items. So we check the model to verify the model is correct or not. And then the deployment. So objective here is we want to use the model to detect, and then we publish to the MQTT broker. We use the VTOS to manage multiple tasks, which we use to three tasks, two call and two priority. The first one is the task name trigger, which is assigned to the first call with one priority. And the second task is cam detect task, which is assigned to the second call with first. Actually, the cam detect task should be the second priority, and the communication task would be the first priority. So let's talk about the second call first. So as the communication task is the first priority, so we need to receive the data first before we publish to MQTT. So I use the platform. Anyway, commute task is for publish to MQTT task, MQTT broker, and I use the function called execute receive to receive the data first. And if they not receive the data, it will stop the process. And the second priority will call, which is cam task. The cam task is basically just for detect and then publish, detect and then it's use the function of the RTOS called execute send to the communication task. But if we not do something about it, it will continue like wait for the data, the cam task detect and then send, and then it will publish to MQTT. It will go on like this. With actually it's not what we want, because we want to detect just some certain period of time. So I put the function called task suspend, so it will stop the cam task, so it not detect. If it not detect, the commute task will not publish to MQTT. And then the trigger task will play an important role in this, because it will, as name is trigger. So if the condition met, it will call the function called vtask resume, which will call the cam task and cam task detect, and then it send to commute task, and commute task publish to MQTT.
Okay, for now, I'm going to talk about the workstation or the Docker. Let's start from my friend talking about, let's say we got the data from the MQTT, right? And start from the the node device one, sending the data to the EMQX, MQTT broker. Let's say we got the data from the EMQX, sending to the node-led, and the node-led will perform the calculation for calculating the data, and I will deep dive to the detail in later. The node-led one will send the data to the MySQL database and store in the database. And as you can see, we have two Grafana and Heidi SQL. The Grafana one is suitable for the visualization that we are going to let the user to visualize our database. The Heidi SQL one is used for the query data in the UI base. And this is our database. We have three tables of the database, and we're going to talk about it later. The next one is the TAIST API. Is used for the API for is about the API for insert or something like that into the database. And this one, the last one, is the TAIST API. Is used for the to let the user to scan the QR code and register their own device. And the last one is the line. You can see the area of the blue dashed line. These are the container, and we have 6 container. The next one is the sequence diagram that showing the mapping port for each container. Let's start from the first container one. Is the MQTT broker. We use the EMQX MQTT broker in order to manage the publisher and subscriber. The EMQX lets us to manage that one. The next one is MySQL. We use this one is the ID SQL. So it's quite easily to see the database, create a database, and we can create the data easily. We have three database, table, the dev legis DB, user legis DB, and device DB. We will going to talk about it later. The next one is Node-RED. The Node-RED one is doing just like the middleman to send to get the data from MQTT and send the data to SQL and doing something like communication between the line and database. Here is the Grafana one. Actually, I just add the user interface one. You can the Grafana one will let you see the graphical interface from the database one, and you can set the priority for the user to be an viewer or the admin. The next one is the TAIST API. As I told you that the TAIST API is the API for sending the data to the database. And the last one is the TAIST API. Here is the API that lets user to scan the QR code and register their device. The next unit is the data pipeline on the Node-RED. Here is the Node-RED one. After we get the data, the payload one from the MQTT, the broker will send this one will subscribe the topic, and the first function, this one will perform will get store only 8 data and sending to the next function. This function is just recheck that our data is more than or equal 5 data. And the next one is this algorithm that we use, starting from the sorting the data and finding the median one. So in this case, we got the number 2, and the number 2 will send to the insert data on the top one and update data. Yeah.
Okay. The next function is a private chat. In the easy way, we use the Node-RED to reply the message from the request from the live bot. The live system will send information on the protocol HTTP post request to the webhook URL. Then in this case, we connect the webhook URL by use the Node-RED. By the way, if you have to use the Node-RED on local, you have to public URL. In this case, you can use the nglog to make the public URL. The keyword is you have to pack your URL into the webhook live API. It is a scenario in our function in the live or chat. The first section is when have some message such as the text or sticker. Initial state from the Node-RED will reply things like the picture 1. In the section 2, if they have command about the sharp register, MAC address, and user, the Node-RED will check the backend in our MySQL and reply your message Okay, if you have a MAC address in our database, you can this device can register successfully. But by the way, if repeat register, the knowledge will reply you already registered. And the third section is mean the command check device on your device register. You can check and insert your name. In this case, if I have already registered by name Fook, you can check and bar Fook. The knowledge will reply all of your device register. By the way, if you check another person, such as checklist in the picture 3.2, the knowledge will reply you, please check your live user. Finally, if you want to delete your old register, you can delete by command delete and MAC address. The response should be device delete successfully. In this, okay, these are for the example code to send the message to Livebot. The keyword is the payload that should be include your user ID. And another one is the channel asset token you can get from your live API when you create it. Okay, let's see our fast demonstration about the live application. Okay, I will skip our dashboard and show in Livebot. This is initial state when you open in Livebot chat. In this case, I send something to get the more detail. The reply from the knowledge send you the some information and the signature. In part of the register, we have two options. First is you can scan QR code that stick in configuration. In this case, it is show in the first time when you register our device. By the way, if you repeat register, in this case, I will copy and paste again. It should be defined already registered. And next, if I want to check our device that I have already done to register, or in this case, you can see the real-time database that update on your table. In this case, developer can see the status register have already updated by user group. And by the way, if you see on database user, they increase the device. If you didn't want to open the dashboard, you can check by command check. That will pull all of device that you have already done to register. Finally, if you want to delete some device, you have to refer your MAC address. Twice delete successfully, and after that, if I want to check again, it should be have only one. Okay, this is all of our Livebot application. Okay, in the final section, we show our dashboard monitor. We use platform governance dashboard. You can apply your geo map. You can apply table or line graph. This is all of our presentation. If you have any questions so far, please let me know. Thank you for your attention.